if you could open Trackvis. Okay, so you now can see my screen. It's a blank page. And I would ask you, so if you didn't want to close your work before, if you can quickly go to File and save your scene, you can always come back to where you were, exactly where you were. If you're not attached to your previous work, just close it and reopen it with me now. This is because Trackvis is quite heavy on your equipment. And if you have multiple versions running, you're more likely to crash. And I don't want you to crash and fall behind or have to go into a breakout room. Okay, so you all know what to do now, but let's just recap slowly. You go into File. Whoops. You open your track or your scene. Here we go. Then you navigate to the data folder that you downloaded. And it will only give you one option to open one file, which is the TRK file. TRK very creatively just means track file. Okay. So if you just click on that one, it will load. Here we go. So you should now all see the tractogram and the white box around it. So next, down here in the image window, so in the image window down here, you have the head with the green plus. So if you click on that one, again, you're in the data folder. I have two options, but you should only have one option in there. Got a surprise for you if you're fast enough. So the MNI 152.me file. If you still only have the same file name, but with the extension GZ, you need to unzip it to open it. If you already did that, you can now just open the beautiful MNI template brain. Here we go. See if I can change my contrast so you see it better. That's better. Here we go. Now you can see the brain. So we still have that white box around our brain. There's two ways of getting rid of it. The first one is to delete the track. The other one is to go into the property window on the right here and find the option slice filters. And you see there's only the y-axis is ticked. You can also untick that. And sorry, we're still in lockdown in France. That was my curfew alert. Right. So you either untick the Y or you delete the track. Same logic. And now you see the full tractogram. So before we move on, just some info. I was asked in the breakout room before why the screen on our computers and on yours might look different. One reason is that we often work with slice opacity. So if you have it on full, the brain is often covering the tracts that you're interested in. And if you have it on very low, you often miss the reference of where you are. So we tend to have it kind of semi-visible. So you still have a bit of orientation, but it doesn't actually cover your tractography. The other question that came up is if you have it in full view and you want to take a picture, for example, of it, or just go and explore how to get rid of the different planes. And that is if you go to the three images down here, underneath all of them, you have the X, Y, and Z boxes. If you just untick it, it will appear and disappear. Okay, so that's how you can play around with that option. Okay, now I want you to delete or hide the tract, ideally delete so it's less strenuous on your computers. And you can expand the window on the bottom because we're now going to place our regions of interest and it's nice to have them in full view. I'm going to zoom in a little bit so you can see it slightly better. So by default, it opens mid-sagittal. but we're interested in association pathways. In the chat, if you could tell me where you think the best regions would be to place our regions of interest. You just had half an hour about the arcuate. I'm expecting some guesstimates. Who's brave enough to go first? Here we go. Supramarginal gyrus. Very good guess. Yes, that will be one of our regions. The supramarginal gyrus is also in the language literature often referred to as part of Geschwin's territory. Does anyone know what the second gyrus in Geschwin's territory would be? But let's go through it systematically. So in order to identify the areas of interest, we're going to start from the lateral surface. So you can see that I'm just moving outwards. We now see here the Sylvian fissure nicely. I'm on slide X 136. So you can also see, whoops, here, that is Heschel's transverse gyrus. So the supramarginal gyrus, we said, is at the end of the Sylvian fissure. So one of our regions of interest will be placed here. Then for the temporal region, Wernicke's area, it's the posterior temporal lobe. And posterior has been defined as behind the transverse gyrus that you can see here. So another region is going to be here. And then the one that most people are familiar with is going to be Broca's territory. And again, you see the beautiful M-shaped here. And that is the posterior part of that is going to be what is known as Broca's. Yay, angular gyrus. That's right. So supramarginal gyrus and angular gyrus together are Geschwin's territory. Well done. Right, so because we're now going to try and segment the 3 segments, there's various different ways of doing it. When we started, you had to draw all the regions on axial slices, and you had to go through every single slice to draw your region of interest. In the more recent iterations of the software, you also have what is known as spheres, which greatly improves that work. So if we just click on the posterior part of Broca's area here, the inferior frontal gyrus. So I'm on X 136. I'm just anterior to the precentral gyrus and coming into our lovely M-shaped here. So I'm just going to click on that part and then go to the image panel here and down here to region of interest. And you already played around with hand draw. Now I want you to use the first one, the sphere. And you see that little dot appear. Yeah, I'm just going to make it smaller for me so you can see the top image better. Here we go. So now we have a sphere in Broca's region, and you can see the correspondence on all 3 planes. Now that obviously is way too small to capture the entire arcuate fasciculus. So what we do is we come over to the property window on the right, second option, which is called region of interest. And I want you to do 2 things here. The first one is that we're going to rename that region of interest. So on the top, it says name. If you double click on sphere, you can change the name. And I'm just going to call it BT for Broca's territory. Okay, so just double click property window, region of interest, double click on the name and change it. You can change it to whatever you want to change it to, just being lazy, so abbreviation it is. The second thing I want you to change is in that same panel, if you come further down, there is an option called radius, and it's currently set to 2. We're going to make that bigger. And here you want to be guided by the anatomy. Interesting. Here we go. So you want to place it on the posterior end of Broca's area, but you want to also slightly capture the ventral precentral gyrus. So cross-reference that your region is still within the brain and you didn't go too big and are suddenly outside the brain. And then that's great. That's our first region of interest. Okay. So now we want to see the magic happen, and you already know how to do that. So you come back to your overview window on the top here, and you currently have one region of interest in there. You right click on Mac or control click on Windows, and it gives you the option to create a new track group. And if I now make my slide transparent, can now appreciate that we actually do capture the arcuate fasciculus. You see the sylvian fissure here, and you see the arcuate arching around the sylvian fissure, going from the frontal lobe here, central sulcus, frontal lobe, into the parietal, arching down into the temporal. Now, you can appreciate from my reconstruction that I wasn't generous enough, because we're not actually getting too much of the long segment. We nicely have the anterior segment here that is stopping in the supramarginal gyrus, but we're missing a lot of the long connections. So I'm just going to make my sphere larger. And this is not random. I'm going to be guided here to see if I move it right here into the deep white matter behind Broca's area, you can now see the beautiful reconstruction of the long segment of the arcuate. What you can also appreciate is that I now moved slightly too far, because I'm also picking up the corticospinal tract here. And not surprisingly, I'm picking up cortical projections from the corpus callosum. But we're not going to worry about those for now. So if yours looks similar to this, well done. Ready for the next region of interest. So we already defined the other regions. So the next one is going to be Wernicke's. So before you do anything, I need you to come back to the image panel and untick that box that is grayed out here, the move box. So that frees your cursor. Otherwise, you're moving your sphere, which is something you don't want to do after painstakingly placing it in the wrong position, in the right position. So now, once you did that, you can come here. So we see Heschel's gyrus here. So we want to be posterior of it. So we click in the posterior temporal region. And we create a new sphere. This is important. Do not draw in the old sphere. Create a new sphere. Check. And now you see I have two spheres in my overview panel. Now, same thing. I want you to come back to the property, select the region of interest if that's not auto-selected, double click on the name and rename it. So I'm going to call it WT for Wernicke's territory. Okay. And then again, we need to increase the size of our region of interest. So mine is 11. And you can see that it ends, if I zoom in, you can see it ends just posterior to Heschel's gyrus. Now, just to demonstrate to you, I have the move option selected. So what happens is if I grab it, I just move my region along. So don't do that. I'm just showing you. Now place it back where it belongs, posterior temporal, behind the transverse gyrus. And because we already reconstructed it from Broca's region, you can also see that we are indeed perfectly placed onto arcuate connections here. So we're missing one more region. To get that last region, untick the move option in the region of interest section here. Then go back onto your sagittal brain and select the supramarginal gyrus. Then again, a new sphere. And we're going to rename that sphere. I'm going to call it GT for Geschwin's territory. And again, we need to increase the size to capture Geschwin's territory, which we just established is the supramarginal and angular gyrus. So this one is usually quite a large region. Now, one thing you got to be careful about is that your regions of interest do not overlap, because if they overlap, you can't dissect them later. Just going to change the color for my Geschwin's territory so it looks distinctly different from the other two. Here we go. Bit of color splashed into the brain. Okay, so once we have that, we are nearly ready to continue. But one thing that we still need to do is we still need to adjust our Geschwin's territory. And the reason for that is because I've just shown you that the arcuate fasciculus has 3 segments, the long direct segment and the shorter indirect segments that do stop in the parietal lobe. But by definition, the indirect segment is more lateral and the long segment is more medial. So what you can already see here is that by placing all the regions on the same plane, they have roughly the same depth. So my Geschwin's territory here is completely encapsulating the long segment. And we know that it should not do that. So we just need to move it slightly outwards. And you can do that either on the coronal or the axial slice. And you basically just grab it and pull it out a bit. It's better still touching it a little bit. Okay, is everyone happy? Can I just get some yeses or nos just to see you're still with me? Ah, lovely, fantastic. Yes, I think. Fantastic. Okay, this is where the fun begins. And again, put your thinking hats on. So we have 3 regions. We got the Broca territory, the Geschwin territory, and Wernicke's territory in the frontal, parietal, and temporal lobes. Now, if we want to dissect out the long segment, which 2 regions do we need to toggle? I'm waiting for suggestions. No suggestions coming through. Don't worry if you're completely lost at this point. Is long segment horizontal or vertical? The long segment is the one that arches around the Sylvian fissure. The long segment is horizontal and then turns vertical. So for the long segment, that differentiation is tricky. So we actually want to combine, let me make this more visible here. The long segment is the arcuate in the classical sense. So it actually goes all the way from the inferior frontal gyrus around the Sylvian fissure to come into the posterior temporal gyrus. So if you want the long segment, that's right, you combine Broca's and Wernicke's, or frontal and temporal. So to do that, we click on, in the overview panel, we click on track 1, and you right click and you toggle with Wernicke's or temporal or whatever you called it. Here we go. And you suddenly see a lot of streamlines disappear. So if I change my opacity, there we go. We can now nicely see the long segment of the arcuate going from inferior frontal as a thick bundle around the Sylvian fissure, which is here. That's the Sylvian fissure. You see Heschel's gyrus here. Nicely arches around it to come down to the posterior temporal regions. So this is the first segment. I want you to go to the property window. The track should be selected at the moment, and you double click on the track name and you rename it. Whatever you want to call it, arcuate, sensu stricto, long segment, direct segment. I'm just going to call it LS for long segment. So now we see that the long segment you can get by toggling Broca's and Wernicke's area. What about the anterior segment? The anterior segment is part of the indirect segment, is more lateral. Which 2 or 3 regions should we connect for that one? BT and GT. That's right. Well done. Okay, so you come back here. You can start from either. So you can start your track from BT or from GT. It will be the same track because it's whole brain tractography. You're not seeding your reconstruction. Here we go. So I start from BT in my case, and you can see the corticospinal tract and the corpus callosum are back. And then I right click on track 1 and I toggle it with Geschwin's in the inferior parietal. And it looks tidy again. Now, the reconstruction we're left with doesn't look dramatically different to what we've seen before, but that will change in a minute. So for now, I just want you to go back to the property window, track, and rename the track. And I'm just going to call it AS for anterior segment. Right, how about the posterior segment? Any guesses? It's very hard now. How do we get the posterior segment? GT, WT, yes, that is right. So we go from parietal, start a new track, and we toggle the parietal with the temporal or Geschwin's with Wernicke's. And now we actually see a change in color. Now that change in color, just briefly, is due to the orientation of the connections as well. And we're going to talk about that in more detail after the next break. So don't worry about it too much for now. Right, and then you know the drill. Property window, track, rename. I'm going to call it PS for posterior. I'm just going to give you a minute to finish yours. Okay, no questions so far, no complaints. So I'm assuming you will see something akin to what I'm seeing on my screen. So now let's get this figure, oops, wrong computer. Let's get this figure publication ready by changing it a little bit. So if we come back here to the overview panel, and I'm going to start with my long segment, LS. If you come down to the property window, you have many options that you explored already a little bit, but one of them is called color code. Sorry, I missed a step. Can you show us again how to make a new track group? Yes, of course, Sabs. So you select the region of interest that you defined as a bottleneck, and you right click and you create a new track group. And then that creates a new track. And if you right click on the track, you can toggle. Cool. Right, so back on the long segment, there's the option down here called color code. And it's currently set to directional. So if you just double click on the directional, you get various choices of how to change it. And we're going to select solid color. Now, by default, that is going to be yellow, but it's just out of habit, the long segment is red for us. But you can choose any color you like. And now we just do the same thing for the anterior and the posterior segments. So I'm going to select the anterior segment in the overview panel and then come down to the property window, color code, double click on directional, change it to solid color, and you can see it turn yellow. And then the last one is the posterior segment, property window, track, color code, directional, double click, change it to solid color, and choose any color you like. So now you see something that resembles the 3 segments. my anterior segment spills over a little bit, but you now know how to fix your reconstructions by placing knot regions. So I'm just going to leave it for now as it is. Just going to untick the plane so you see the tract. Now, if you spin it around, you can appreciate that the long segment of the arcuate is indeed a longitudinal connection around the sylvian fissure that is more medial than the indirect segment that here is lateral to it, so more close to the cortex. Right, so this is still not publication ready. So what you can do is come back to the overview window, and you see on the top your regions of interest. If you right click, not any particular region, but just the heading regions of interest, you can hide them all. So if we do that, boom, they disappear and it looks way prettier already. For the long segment, I'm just going to show you briefly. If you come to the property window and track, there's a render option. And in render, if you double click on the line, you can change it to tube. And then the radius by default is 0.5. If you double click on it and you put it to 0.05 as the default, and you put it to 0.2, you all of a sudden see those nice streamlines appearing. Okay. And that's just more aesthetic than flimsy lines. But that's also why it's easy to mistake the reconstructions as actual axonal connections, because they look very much like axons, but they're just made to look that way. So bear that in mind. We're not actually looking at individual axons, we're looking at streamlines. So I'm going to change mine to make them look pretty for you. There we go. A beautiful arcuate fasciculus for you with all the 3 segments. So for those of you who couldn't resist and also did it, you will now realize that your 3D rendering is most likely a bit more clunky than it was before, because you're now taking up more memory. But one thing you can do now, and I'm just going to give you bit of time to do that, is you can explore the anatomy. So if you bring in the sagittal, ooh, nice screenshot coming through. Lovely, that looks very good. I like the independence in its color scheme. Very good, Sabs. Lovely. So one of the things you can do now is bring the surface of the brain back and actually look at the anatomy. So now we see here, I'm probably slightly too far lateral, so if I move slightly inwards, here we go. So here is our sylvian fissure again for reference. This is Heschel's gyrus, and we see that we're nicely arching around the sylvian fissure. And for the long segment, let me show you the long segment only for a minute. Here we go. So you nicely see that it's arching around the sylvian fissure. You also see that it's arching slightly outwards towards the temporal regions. And you can see that we're now here in the ventral precentral gyrus and Broca's territory here. And you can also see that the projections in the temporal lobe tend to be slightly lower than were originally anticipated. So you can just scroll through and appreciate the tract in relation to the template. Now, one thing you also can see here is that our reconstruction actually reaches the frontal pole, which is something you do not see with the tensor models. So for classical DTI, and I'm going to explain the difference in the next session in probably more detail than you ever wanted to know about it. But in classical DTI, it tends to stop here, and we're not getting these frontal projections. So this is already an advanced tractography data set, And that's why you can see it reaching all the way forward. So if we bring back the anterior segment now, here we go. Now, as I said, I didn't clean it up yet, but we can nicely see that it lays on top of the long segment, more lateral. Scroll out a bit, we can nicely see here the connections to the supramarginal gyrus. And we do the same for the posterior segment. So we have supramarginal and angular gyrus, and we have the temporal projections. Now, as I said, if you want to come back to this exactly, you just go to File and Save Scene As, and it will save your reconstruction, it will save your tracts and your regions of interest. So you can literally just close your computer and come back to exactly where you were. Right, so that is the magic of the 3 segments of the arcuate fasciculus, and we actually do find ourselves with a little bit of spare time. I told you in the beginning that I had one more file than you did, and if we had time, got a surprise for you. So here's your surprise. Download it from the chat and save it in the same folder that you have the data in. Okay, right. No complaints is a good sign. So this one is going to be slightly different now. So what I just sent you is the meta-analysis of language activations as it is available on Neuroscience, the website that we showed you this morning, earlier today. And I want you to open that in Trackvis. And the way you can open it is as a region of interest. You don't open it as a map, you open it as a region of interest. So you come down to region of interest, and you already know the hand draw, you know the sphere, and then you have from Niftify. I want you to use that option now from Nifty, and it will open a window and prompt you which file to open, and you should now have 2 files that you can open, the MNI 152 and the file that I just sent you, which is the 1 millimeter Neurosynth language associations. So that's just a very classical neuropsychological language test that we commonly use. And you see in my preview here already the activations. So just go ahead and open that, and boom, here we go. So you now have a new region of interest appear in your overview panel, and you cannot miss the image is loaded in the main screen. Now you can go and explore all the activations, and we can already appreciate that the arcuate fasciculus is completely encompassed by those functional activations from Neurosynth. Now this image at the moment looks extremely messy, but if we come back to the property window here and we select region of interest, you can see that there is a threshold to play around with. And currently the threshold goes from 0.7 to a high threshold of 15.9. Those are the Z values. So what we want to do is we want to cancel out the low standard deviations or the low Z scores, and only are left with highly significant activations. So to do that, I'm just going to highlight the low threshold and set it to 5. So now my fMRI is thresholded 5 to 15. And if we make the brain slightly more transparent, or actually let's take it out completely for a moment now, you can see that the arcuate is hitting a lot of the activations for semantic functional activations. If we bring the brain back in, you also see the anatomical references. That is all I have to teach you for the association pathways. Feel free to take your snapshots, save the scene, keep it forever or toss it depending on how you feel about it. I'm around for questions. We're going to have another 15-minute break, and I see you afterwards. Thank you.